Hello, my name is Abby Rogers, and I will be facilitating this webinar. If you have any questions during the presentation, please submit them using the Questions tab in the control bar, and we will respond to them at the end of the presentation. I will now hand this off to Ryan Reimer, Project Manager for DrySteam.
Good morning and good afternoon. Thank you, Abby, for the introduction. Like Abby mentioned, I am the Product Manager at DrySteam for our water treatment systems. Hopefully, most of you got to see the first one in a series with the softener applications and what DrySteam has to offer. This will be a continuation of that training, talking about dechlorinators as a technology and what our particular offering is. The overview of today, we're again going to start with water quality and the purpose of water treatment. Hopefully, this high-level overview will give you a little bit different context in the same regards to why water quality matters and why water treatment matters compared to the first series, followed by dechlorinator description, then applications, followed by DrySteam's dechlorinator offering, followed and finished with maintenance expectations. And as with the first one, we will take questions at the end, so please prepare those as we go, and I will get to them at the end. So the first slide here is talking about, what's in your water, how do you find out what's in your water? This example is a water treatment test report from the City of Eden Prairie. This is something that they're by law required to publish, essentially for the consumers, for the people that are using it in their households, or as drinking water in commercial buildings, etc. Essentially, the goal of this report is to make sure the water is safe for human consumption. I know I talked in softeners and I will talk in ROs about how this doesn't give us the full picture. However, in a majority of dechlorinator applications, this is what we need to know. The chlorine is the disinfectant right in the middle of the screen on this. They're saying the maximum allowed conditions 4 ppm and their average results a little under 1 ppm. So the biggest thing here, and as I look at this and as we all look at this as it relates to dechlorination applications, is there is chlorine present. The other thing that could potentially be on here is a chloramine, also another disinfectant. But this is really important to just understand that, yes, they do have it. Understanding that it's 1 ppm really doesn't matter in the case of us wanting to take it out anyway. And we'll talk a little bit more about function of the activated carbon, which is the functional group in this technology. So again, why is water treatment necessary? The top left photo, and as we go through these photos, really talk about understanding what's in our water, how can we maximize equipment life, how can we prevent maintenance, etc. So the top left is a depiction of scale, which won't be pertinent to today's conversation beyond knowing that ROs remove scaling potential and dechlorinators thusly are upstream of them. But on the top right of the screen with the bathtub of dirty looking water, a good representation of potential contaminants, whether that's iron or a suspended solid like dirt, etc. Bottom left is a depiction of, in this case, chloride corrosion, and more specifically on a weld. Why water treatment is important, obviously minimize that aspect of it, which will be talked more about in the RO series, specifically chloride removal. And then lastly, the bottom right photo, we're looking at a glass of water that has different biological aspects to it, whether that's bacteria or viral or fungus based. And this is really the picture that explains dechlorinators. So in the sense of adding disinfectant to your water, they do that to prevent these things from obviously getting people sick. And when we talk about dechlorinators, typically we're not talking about removing that disinfectant besides for process. The one exception is if you have a Brita filter or your refrigerator has a built-in filter in it. Point of use systems really minimize the potential impact of bacteria growth because it's a very short distance between you using it. So dechlorinators in general, what's the function? There's many different functions to dechlorinators. The ones we're going to talk about today relate to water filtration. So in more particular ways, chlorine and chloramine reduction. How that works is essentially it's going to give off an electron. The carbon's going to give electron to the chlorine gas, that's a disinfectant, turn it into chloride. I mentioned adsorption in here. So as you guys are out in the marketplace or you're an end user using different activated carbon filters, some things filter air, some filter water for other contaminants, particularly in the organic range or heavy metals, depending on. The other piece, why do we want to dechlorinate water? Well, that's to, again, maximize the lifespan on the equipment and minimize the maintenance aspect of it. The biggest focus, at least as it relates to historical dry steam, and a majority of the marketplace, is you'll see a chlorine filter, a dechlorinator upstream of an RO. The biggest reason for that is those RO membranes will oxidize and essentially lose their effectiveness over time as they are exposed to oxidative disinfectants. Why does that matter? If you look at the marketplace, I guess if you look at a 4-inch membrane, you'll see a price somewhere in the $300 range. If you have 10 of those per system and you're only getting half a season, that's $3,000 right there, right off the bat, that you're going to spend each year on a maintenance perspective. Obviously, that can be avoided in that investment. Some of the other reasons why upstream of DI resin, and also to prevent or to protect plant material from being oxidized. That plant itself is biology, and the chlorine's there to destruct it. So the other note on this page is there's different forms. Again, just like there's different reasons to use activated carbon and dechlorinator technology. The most common one is using a nutshell, particularly coconut, to give the most micropores as they activate that. Again, brief description of the function. This is a lot simpler than a softener. Regarding our offering, during service, raw water comes in, goes through the control head, which I'll show in a moment, down through the activated carbon bed, and collected and brought back up through a clean water tube. I forget as we're doing these webinars, you guys can't see me, in quotes, clean water. Obviously, it's only really functioning on the chlorine aspect of things and doesn't remove other, let's say, inorganic dissolved solids. Backwash, again, simpler than a softener. It's one cycle that it goes through. It's typically about 8 to 15 minutes, depending on your site conditions. So what that backwash is mainly doing is reversing that flow, lifting that bed up, and removing any fines or suspended solids on the top of that bed. That's very important for the sake of the mechanical system. The more solid you have on top of the bed, the more restriction in your system. And really, if you choose not to do it, that restriction can build over time and you can have dynamic pressure issues. So some applications for dechlorinators. There's definitely less application for dechlorinators as we talk compared to softeners or ROs. But again, this gets paired upstream of an RO. So the first picture on the left is a reverse osmosis depiction, and in this case, it's Dry Steam's RO 400 series. And what we're doing there again is protecting that investment of those membranes and really extending the lifespan of those membranes. It is a requirement that the source water to our systems is dechlorinated. again, 1,000 ppm hours, if you have 1 ppm and you run for 1,000 hours, or in some places half a season, as that gradually breaks down that membrane, your water quality is going to go down. What's bad about the water quality going down, you may ask? It's, well, your investment goes down, but really why did you get the RO in the first place? Now, if we're talking ROs for humidification applications, the water quality that we're expecting to get at, let's say, a GTS LX is hypothetically 10 ppm of RO water, TDS. Over time, it'll go to 11 to 12 to 13 as that membrane breaks down. That can have a negative effect in the sense of what you're trying to prevent with water treatment is that end up going to happen because you're sending poor water quality downstream. The next photo, indoor agriculture, where we see these. Some facilities like to use RO. So this might be a good application for RO, but if they're not using RO, they're going to at least want for it to be dechlorinated. The plant's a biological life form. If you oxidize that life form, it tends to struggle for a little bit. The at-home example that I like to think about, at least growing up, I had fish as pets, and you always let your water dechlorinate with a tablet thrown in there, or you let it sit on the counter and it'll dissipate. Same concept, different life form. Again, dechlorination helps prevent that. Laboratory makeup, where this is typically seen from a dechlorinator aspect, is upstream of DI bottles. These laboratory facilities have makeup systems. Sometimes they have ROs, sometimes they take city water and go right through DI bottles, deionization bottles, to get a low conductivity or high resistivity water. Same with that resin. Just like the membranes has a potential to break down to protect that investment. So what is DrySteam's dechlorinator offering? We have a couple different options. The first one, the blue image on your screen, right, pretty much in the center, is a cartridge style wall mount cartridge. It is a consumable piece that we replace periodically, anywhere from 6 months to a year, and I'll kind of talk a little bit about maintenance and what that true expectation is. Along with the far right side, DrySteam's tank style dechlorinator. Very similar, and we'll talk about the componentry in that system and what we have to offer. But again, it's a control valve, and activated carbon is filled inside there. Some different flow rate information. So the cartridge style is great for low flow rates. The thing we're really looking for is contact time. I didn't put this exact info in the presentation, but I believe Pentair water talks about 5 grams of activated carbon equaling 32,000 square feet of surface area. So this carbon, as you break it down, becomes more porous. But along with that, we do need contact time to effectively remove and have that reaction occur. And then same with the inside of a tank style, it's granular activated carbon. I have a picture of that on the next slide. Actually, excuse me, 2 slides from now. So water treatments systems as a whole, the first thing in this system is a dechlorinator. Again, to remove the chlorine aspects. Water softeners was talked about last week, also viewable on our website to view that recording. And then next webinar will be reverse osmosis. The one note about the dechlorinator, at DrySteam, we choose to put that on the upstream side of the system before the softener. There's really a couple different places you could place it. You could put the softener first and then dechlorinator, but this is how we set up our systems and have them coordinated. The note here is skidding is available, essentially for that plug and play solution. A high level overview of the different components. Nothing real exciting here. Several different things make up the system. The carbon is essentially your heart of the system doing the reaction. There are control valves directing those two different flows between service and backwash. The distributor is the barrier between the clean and the raw water, essentially. FRP tank, a vessel to hold that and support gravel to support that distributor and hopefully reduce pressure drop. Again, skid mounting, ease of installation, plug and play. You'll have typically, this would be when you purchase a softener as well. A one tank system has one electrical connection. It has one inlet, outlet, and drain. But really when you're pairing the combination of these, this is where it can be advantageous to essentially drop this in and service the application. Some good things to know about this as you're out in the field when you're looking at different applications or you're hearing different terminology used. Activated carbon filters is another name for dechlorinators in the marketplace. Granular activated carbon is talking about the media itself. The iodine, the molasses, the abrasion things. If you see these things, I put this in here. This is like heavily engineered spec, probably very sensitive applications, whether that's food and beverage. You know, if you see that those kind of very specific things come out, definitely have a conversation with us to see if it's a good fit for dry steams application. There's plenty of applications that are great for our systems, and then obviously some that are a little bit beyond what our design typically would handle. Some other good things to know: if you see upstream of an RO system a chemical feed, it could potentially be chemical feed to remove the disinfectant. What I like to talk about there is if you see that, essentially a magnitude of things can happen. You could lose power, number one, which your RO wouldn't work anyway, or you could run out of chemistry. You could have the wrong feed rate on your chemistry. Where the dechlorinator really has an advantage is it's essentially a dumb device. You send water through it, it treats it, you send it out. Obviously, all things considered, you need to make sure it's still active, and that thing on the maintenance end, and also designed correctly on the front end. But that's really the biggest advantage of trying to do carbon over chemical, not to mention the consumable rate at which chemistry is consumed. So some maintenance on dechlorinators. How do you know if your system's working properly or not? The first thing that you want to make sure it's doing is removing chlorine. That's the main purpose of a majority of the water filtration applications. That can be done with test strips or other analytical methods. If you want to get more granular in how many ppm are coming in versus leaving, you know, a different drop test might be appropriate. What we see on activated carbon life, so this is the tank style perspective. The cartridge filter tends to be consumed a little bit quicker, particularly because of it not being able to remove solids with that backwash cycle. In my experience and in dry steam's experience, 1 to 2 years lifespan on this carbon for this type of application. Obviously, there's cases where, you know, it breaks down quicker. It might be 6 months, might be, you know, 3 to 5 years. I've heard also thrown out in the industry. But when it comes to replacing that, media can be purchased through Parts Online, Dry Steam, for our reps out there listening to this call. And then also, the old media is typically removed via vacuum truck. Vacuum truck or a vacuum that can handle the solids. Other routine maintenance would be understanding if the seals on that control valve are leaking by, just like a ball valve or a butterfly valve. You check the seals and make sure there's no bypass. Similar thing in this valve. Recommended check once per year. Some information for sizing so we can help, you know, any end user on this call or any engineer or representative on this call is what's the type of application? What are the flow rates, min and maximum? Again, we talked about contact time. We want to really understand what we need to treat. And the biggest yes or no question is there chlorine or chloramine present? That's the main purpose. So if that's not present, obviously we need to talk about what that water treatment need is. available space. The biggest thing that I notice is the head space. From a maintenance perspective on dechlorinators, you need to take that head off and be able to access that. That's where I've seen it, placed in different areas that have a head constraint, and provides an additional challenge. Are there any electrical requirements? I didn't talk about the specifics, but you can pull our product catalog regarding electrical. Our systems come in 120 volt single phase. And then lastly, are there any special requirements? With that, next step, obviously contact your local representative today for your next application. Get in touch with us if you have any questions. And at this time, I will take questions from the audience. So I'll give a few minutes to write in questions if you guys have anything. So the first question is EBCT question mark. So I left that on the screen. I didn't want to beat that one down too badly, but EBCT, as we go back here, is empty bed contact time. So essentially, how much contact does that water have with the activated carbon to essentially neutralize that disinfectant? So EBCT, sorry I didn't describe that acronym, but that's what it stands for. As I wait for questions to come in, I did briefly mention the next, this is the second part of a 3-part series. There's one more event talking about reverse osmosis and what dry steam has to offer.
All right, Ryan, I'm not seeing any more questions come in. So you care if we wrap this up?
I see a hand raised from Douglas. I'm not sure if he can type it or if you can unmute him to ask a question.
Sure. Oh, there it is.
The Cyprian water report. So that's definitely a good question. And kind of the thing that I like talking about regarding the water report is each city has to require or to report a certain thing to the regulatory industry for consumers. These things regarding disinfectants are on the top. They kind of segment this out. Not all water reports look like this, but essentially what's, the couple different things that you're going to see are what is a contaminant it's searching for. Now, whether this is a city report or whether this is a third-party lab running these reports, typically you're going to talk about what the contaminant is, what is their testing range, or what's the maximum allowed range is typically how that's framed. So that MCL piece is maximum allowed contaminant level. So for example, if we look at chlorine on this screen, if you look at 4, that's 4 ppm of maximum allowed for a consumer. And then you look at the next column to the right, the one that says 0.8 to 1.2, that's talking about the range over that reporting year. It doesn't tell you how often they pulled this data. They probably pull it daily, and then they average that out. And then they kind of talk about contaminant. If you look at a third-party report, they might not say typical source of contaminant as we look at different inorganics. And typically the answer would be, well, it's in the groundwater. When you pull that up from the aquifer, it's already prevalent. It wasn't anything added in. Hopefully that answers that question. And obviously, if there's a water report that you have out there and you need some analysis, please contact Dry Steam and we can work through that. Any other questions? Abby, do you see anyone I was talking in? I got in the zone. I wasn't paying attention if there's more.
There is another one. When finished, the activated carbon, how do we replace it? Just the activated carbon?
Yep. So, the cartridge style is very straightforward. You essentially unscrew the housing and replace that cartridge, which it has embedded on the carbon on there. And just like any other pre-filter, if you're familiar with our high pressure atomization or our RO series, the tank style is removed typically via vacuum, because if you look at the offering, there's only a top tank connection, and you're going to get in there and essentially pull a vacuum on that, suck that out, kind of like a wet back. It depends on the solids. But when you're doing that, and you're sucking that water out, it's going to be very hard to separate the gravel from the activated carbon that's in there. Those are the two types of media. So typically, the best plan is to replace them both at the same time and plan for that. It's very hard to separate those two out. All right, well, if I'll let you wrap it up, Abby, but if anyone has any other questions, please contact us.
We do have another question.
Okay.
If using a soft water pretreatment only, do I need a dechlorinator?
So it really depends on the customer's goals, but typically not. The dechlorination is really to protect different processes that we'll see that in particular RO systems. Regarding soft water, it's typically the lifespan on the softener was talked about in a previous slide. Even with chlorination upstream of it, that resin should last about 5 to 10 years. So the risk essentially outweighs in the industry adding a dechlorinator above just before just a softener, not to mention additional capital investment and water utilization. It's definitely not necessary. I've seen obviously customers that prefer to do that from a chlorine removal perspective, but it's definitely not necessary.
All right. If anybody has any other questions, please reach out to marketingmail@drysteam.com and we will be sure to pass that along to Ryan. Thank you everybody for attending our webinar, and hope you have a great rest of your day, everybody. Thank you.